Alright, everybody, let's talk about this question. Let's just kind of figure out what it is that they are giving you. The first thing that they have here is that the information is tabular, the time is in minutes, and the function values are the degrees Fahrenheit that the water in the tub is accumulating. And notice that there's a few pieces of information that are important. First off, that you have a strictly increasing function and that he is twice differentiable, which means you know that he's also continuous. And so if we were just to discuss the first piece of this question, it says use the data in the table to estimate the derivative of W at 12. Notice that the values they gave us around 12 were 9 and 15. And so to work this question out, what you would need is the difference quotient, W of 15 minus W of 9 all over 15 minus 9, with those values plugged in, and then you should, since this is calculator active, you should have gotten an answer of 1.017 if it was rounded, or if you truncated it, which just means to cut it off 3 decimal places, you would get 1.016. Either of those two answers would suffice. You needed the setup, and you also needed the interpretation. Please don't just write 1.017. Put the setup there to show the reader that this is how you got to your answer. And then the interpretation here would be the water temperature is increasing at a rate of approximately 1.017 degrees per minute. That is very important to add there. At the moment t equals 12 minutes. So you could say the rate of the water temperature, however you want to say that, but please do not forget degrees per minute. That's important. Question B is asking you use the data in the table to evaluate the integral from 0 to 20 of w prime of t dt. Notice that they're asking you to integrate a rate, which means to accumulate. And so if you were asked to find the integral of the derivative, then you would take the antiderivative, which would be the function value at 20, minus the antiderivative, which is the function value at 0. And so those values will just be pulled straight from the table, 71 minus 55, and you'll get 16. And then it also has, using correct units, interpret the meaning of this. So you realize that that would be the accumulation or the change in the water temperature over the interval from 0 to 20 minutes. Please make sure that you're putting over the interval from 0 to 20. Don't just say it's the change in temperature without a timestamp there. So you got a point for having 16, for having your value, and you get a point for having the correct interpretation with units there. If you do not include units, or if you said the units was degrees Fahrenheit per minute or something that was incorrect, you would not get that second point. Okay, and part C is saying here to for 0 to 20 minutes, the average temperature of the water is modeled by this integral right here. Remember, 1 over 20 in the front means average. You want to use LRAM over 4 subintervals indicated by the data in the table to approximate this value. What does the approximation, would it be an overestimate or an underestimate? And explain why. And so if we look at this answer down here, the 1 over 20 continues on. Make sure that the work that you have is mathematically accurate, that you aren't separating things by equal signs and they aren't actually equal to where you have a 1 over 20 in the first part and not in the second part. Just continue it on throughout. And notice that you need to use LRAM, and these intervals are not equally spaced. And so you have to calculate each one separately. So you have 4 times the first value of W, 5 times the second, 6 times the third, and 5 times the fourth. You would not use the last one because we're doing LRAM and not RRAM. When you work that out, remember this is calculator active, you should get 60.79. Okay, and All it's asking at this point is this an over or underestimate? And that information is coming from the fact that you know this function is strictly increasing. And if you would just happen to draw a picture of this function, if it's strictly increasing, then you know that your rectangles are falling underneath your function, which would be an underestimate. So you would say the approximation is an underestimate because the left Riemann sum is used and the function is strictly increasing. So you get a point for the correct left Riemann sum. That's just this setup right here. That's a point. Okay? This would also suffice as your point. One or the other, either one would get you the point there. And then you get a point for the correct approximation, 60.79, and then you get a point for your underestimate with your reasoning. Okay? The last part of this question is asking you what's going on outside of this 20 minutes. Okay? It says for 20 to 25 minutes, the function w that models the water temperature has the first derivative given by this function right here. Sorry. So here is our rate function. Based on the model, what is the temperature of the water at 25 minutes? And so we want to figure out the actual change in temperature over that 20 to 25 minutes. And so you need to make sure that you include your integral from 20 to 25 minutes of your rate. But then don't forget to add your 71 degrees to it. That was what's actually going on at 20. So this is a fundamental theorem question where you have W of 25 is taking into account your initial condition, these two values right here, the integral from that initial condition to 25 of your rate function. That again is just something that you can plug into your calculator and you should get 73.043. You get the point for just having the correct integral set up, this value right here. And then you also get a point for the correct answer. That's a 2-pointer. So that was question number 1. Let's look now at question number 2, which is a tad bit different. Actually a lot different. This is going to be a rotation question and a volumes question. Those typically always will show up on the AP test. Okay? It gives you the region of R. It's the natural log function and 5 minus x. You are asked to find the area of R. You could either do this with vertical strips, all right, where you are integrating from 1 to this intersection point up here of the top minus the bottom, which is in essence 0, and then integrating from that intersection to this value out here, which is 5 of the 5 minus x function. Notice that they did put some information out here in the solution where the two functions are equal at that current x value. So you know that this point out here is 3.693, comma, and then your y value is 1.307. And what they did to kind of keep it simplified throughout the problem is they denoted that to be a and b throughout the whole problem. So you can use a and b as your limits in the rest of the problem. So you could have this set up this way with respect to x's, okay, where you're going, the area would be the integral from 1 to a, this 3.69344, of the natural log function, plus then the integral from a to 5 of 5 minus x dx. And when you type that in, you would get 2.986, or if it's truncated, 2.985. Or, let's do this with respect to y's. If you took your functions, we have y equals the natural log of x, and I solved those for x, that would give me x equaling e to the y. And then 5 minus x equaling y, if I solve that for y, then I would have, I'm sorry, for x, I would have x here is equal to 5 minus y. Okay? You'll notice that my far right function would be my 5 minus y, and my left function would be e to the y. And so if I did horizontal strips and I integrated with respect to y, I would integrate from 0 to the y value of that intersection, which would be b, of my right minus my left. That should still give you 2.986, or if it's truncated, 2.985. You get a point for having the correct integrand. That is just what is inside here. Okay, so if you have it set up in either case correctly, where you have the correct integrand, give yourself a point. You have the point for the correct limits, so don't miss silly points with wrong limits, and then you get a point for your answer. So there's a 3-pointer. If we looked at part B rather, we have a situation where you have region R is consisting of cross sections that are perpendicular to the x-axis. Okay, so we have those strips going vertically. Oh my word. All right. And then write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. Notice they are saying that those are forming squares, so if you can kind of visualize this, it's coming out at you like so. Okay? And so what we need to do is come up with the formula for the area of this slice of bread, which would be a square. Obviously squares have an area of their side length squared. Oh my word. And what we need to realize here is that that side length is the value of the function. So your area formula would be, for the first section, you would have to set this up in two separate integrals here, folks. The first one would be the natural log function squared, and then the area for the second function would be your 5 minus x squared. And so you can see your setup. The first part would be from 1 to a, which is the 3.69344 of the natural log function squared, plus then the integral from a to 5 of 5 minus x squared. And so you get a point here for having the correct integrands, those pieces behind the integral, and then your point if you had the correct expression completely there, the way it's shown. Okay, again, don't take the time to do anything other than just setting it up. Those questions are wonderful, aren't they? You just have to show them that you know what you're talking about. And then part C says we have this horizontal line y equals k that's dividing this area up into two equal regions. And all we have to do is set up an equation. There's two ways you could essentially do this. If you have, there's probably more than two ways, but the two most widely used ways, this would be k right here. And I want region 1 and region 2 to have equal area. And so what they have down here is they have that the integral from 0 to k, you have to go with respect to y's here because you have horizontal strips, if you can see that, would be your right guy minus your left guy. And we know that the area already is equal, the total area is equal to what we got in part A. So they took the 2.986 and they set it equal to half of 2.986. That would be one setup. That the area from 0 to k would be equal to half of the area that we found in part A. The way I kind of thought to go about this was to say, well, I know that the area from 0 to k of my 5 minus y minus e to the y dy would have to equal the area from k to b, the y value of that intersection, of 5 minus y minus e to the y dy. Okay? And so either situation there would get you the correct answer if you had it set up in either way. So you get a point for the correct integrand, you get a point for the correct limits, and then if your entire equation is set up correctly, that's the third point. All right, we'll see you all later. Bye, everybody.